Hello there, and welcome to notes over our second conic section, which is the ellipse. So I said there's going to be four conic sections we talk about. There are parabolas, which we spent a little more time last time. There's ellipses that we're talking about today, which in layman's terms is essentially an oval. There's circles that we'll get into, and then there's the hyperbola. Now the ellipse and the hyperbola are two that they're brand new, and so they require a little bit more time as far as explaining the equation and all the parts about them. So this figure right here on the notes is an ellipse. Okay, it's an oval shape. Now in an ellipse, a few things I'm going to get into in this diagram here are parts of the ellipse, the equation of the ellipse, and all that stuff. So if you notice here in the ellipse, it is an oval. Now, it could be a sideways oval, or it could be an oval that is vertical. Okay, and we'll talk about the equation that determines whether it's going to be sideways or whether it's going to be up and down. Okay, we'll get into that. Now, in an ellipse, every ellipse has a middle point right here, and this point is called the center. Just like a circle has a center point. In a parabola, we talked about a special point inside of it called the focus point. Well, in an ellipse, it actually has two focal points. So you notice those are highlighted right here. Here's a focal point, and here's a focal point. So there's two focal points, and we call those focal points foci. The plural of focus is foci. So there's two foci, okay? And we'll talk about how to find them and where they are and all that stuff. Every ellipse has 2 points on the end of, well, we'll call it the major axis. I'll label it here in a second. But if it's elongated horizontally, then the vertex points, that's what these are. Here's a vertex. Here's a vertex. You notice the shorter length here. I'm not going to name the top and bottom vertex points. There's only two vertex points, and they're at the end of what we call the major axis. So the major axis extends from one vertex point to the other. So that whole length there is called the major axis. And notice that all the special points lie along the major axis. Your center point, your two focal points, your two vertex points, they're all along the major axis. There's also a minor axis. The minor axis is the other length. So from top to bottom here, that whole length is called the minor axis. So it has a major axis, that's the long axis, and it has a minor axis. Okay, now, the equation of the ellipse. Okay, I'm going to kind of delete a few things here and talk about the eraser tool, the erase lines drawn with the draw tool. I'm trying to figure out how to work this app, but I think I got it figured out. Okay, so here's the equation of the ellipse. It's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. I'll let you write that down. Now, we've kind of already seen this formula a little bit first semester in the circle equation. And you don't need to write this down, but if you remember in the circle equation, it was x minus h squared plus y minus k squared equals r squared. So there is a little bit of familiarity with the form of the ellipse. Now, a few things about it. I need to talk about what all the letters stand for and all that good stuff. Now, the center point is the same as when we talked about the circle. The center is the ordered pair h comma k. H comma k. So if you look at the equation, the h is the one that goes with the x, parentheses, right here, and k is the one that goes with the y. So it's h comma k. Notice the signs flip. If it's x minus h, then the x-coordinate is positive h. So the center is h comma k. The distance from the center to one vertex point, okay, so not the entire major axis, but half of the major axis, is the a value. So if you look in the equation here, it says a squared. Well, a, if you take the square root of that number, is the length from the center to the vertex point. Well, then if you might guess, b is the distance from the center to an edge of the minor axis. So that's b. And notice here it's b squared. So the square root of that bottom number is going to be your b value. Now, there is a relationship between a, b, and c. And I haven't once talked about c yet. But c is the distance from the center to the focus point. That is c. We call that c. So it's important to know in the diagram what all these letters stand for. A is half of the major axis. That's the distance from center to vertex. B is half the minor axis. That's the distance from center to, and that top point doesn't really have a name, but the distance from the center to the edge of the minor axis. C is the distance from center to focus point. Now, each focus point is the same distance away from the center. So both those distances would be C. Okay, there is a relationship, and this little equation is really important to know. There is a relationship between A, B, and C. And it looks like the Pythagorean theorem. It's not, but it looks like it. It's A squared minus B squared equals C squared. This little equation is going to be pretty much used in every ellipse problem. And again, this is the relationship between A, B, and C. It's A squared minus B squared equals C squared. Okay. Now I said I would tell you, based on the equation, how you know if your ellipse is going to be horizontal or if it's going to be stretched vertical. Okay. Now the vertical one, I'm trying to shrink this here. A is the bigger number. That's important to stress. A is the bigger number. It has to be, because if A is half of the major axis, A has to be bigger than B. So here's the equation you could have if it was stretched vertically. You could see it this way. X minus h squared over b squared plus y minus k squared over a squared equals 1. Now look here. Wherever the bigger number is, so notice on this top one, the bigger number was under x, so it was stretched horizontally. Here, the bigger number is under the y term, and so this ellipse would be stretched vertically. And so what that would put your center in the middle still, but now your focal points would be here, and your vertices would be up and down. So your major axis would now be vertical, your minor axis would be horizontal. Okay? So the direction of your ellipse all depends on which letter is the bigger number under. Okay? So if it's under x, it's horizontal. If it's under y, it's vertical. So that's all the terminology and notation and all of that. We are going to get into a few examples, and hopefully a lot of this starts to make sense. So I'm going to go to the next slide. All right. I don't want to get into the definition right now. We could talk a little bit about that next class. We'll take a look. I just want to do the few examples for your e-learning. All right. So I first want to look at number 3. All right. I want to look at number 3 first. So I'm actually going to flip to the next page. I have no idea if I just picked the right option. It said, since I went back and already was on this slide, it gave me options, and hopefully I picked the right one. And all this makes sense, and you can hear this okay. So, number 1 says, find the coordinates of the foci and lengths of the major and minor axes of an ellipse whose equation is given right here. And then draw the graph. So, in the ellipse, we need the equation to equal 1. That's the part of the definition of the ellipse. The equation equals 1. And so we can make any equation in the world equal 1. We can take this equation that's given and just divide everything by 144. Divide by the constant. So divide by 144, divide by 144, divide by 144. And so in doing so, we are going to have, well, 16 over 144 reduces to 1/9. So we have x squared over 9 plus 4 over 144 is 1/36. So y squared over 36 equals 1. So you first have to take an equation. If it's not in the ellipse format, you have to put it in the ellipse format. Now notice here there's no parentheses, there's no quantities. All that means is our center is at 0, 0. So right at the origin is the center of the ellipse. Okay. The bigger number in this case is under the y term. 36 is under the y term. That means our ellipse is going to be a vertical one. All right, so we have to keep that in mind as we kind of go through everything here. So a squared is 36. And b squared is 9. So that means a is 6 and b is 3. And we use those values to essentially draw the ellipse. So from the center, since we know this ellipse is vertical, we're going to go up and down 6. 1, 2, 3, 4, 5, 6. Right here. 1, 2, 3, 4, 5, 6. So those are the vertices. And then the edge of the minor axis, we go left and right 3. 1, 2, 3. 1, 2, 3. And we see the ellipse form. And we just draw a nice little ellipse. There you are. And then the other thing we want to find, well, I guess looking at the directions, is find the coordinates of the foci and lengths of the major and minor axes. So we need to answer those questions. So the major axis, if A is 6, the major axis, I just spelled that completely wrong. The major axis is 12, because A is half of the major. The minor axis would be 6. The other thing we want to find is where are those dang foci? So we use the a squared minus b squared equals c squared equation. We know a squared is 36, b squared is 9. So c squared is 27. So c is the square root of 27. But we want to simplify everything, so if you simplify the square root of 27, you guys all have your own strategies in doing that, but c would be 3 square root of 3. So remember what that means. That is how far away from the center the focal points are. And notice if we're moving the focal points up and down from the center, we're changing the y values. So the foci, the x coordinate is going to stay the same because we're not moving them left and right, so it's still 0. But now we're going to take the y value of the center and go up and down 3 radical 3. So if you take 0 plus or minus 3 radical 3, you get plus or minus 3 radical 3. But we do need to know that decimal approximation. It's about 5.2. So from the center, go up and down about 5.2. This is not going to look good. Right there. Right there. There you have it. Now we got 2 more. So this one asks you to write the equation of the ellipse. We need to write the equation of the ellipse. So we have to find A, we got to find B, we got to find the center, all that good stuff. Well, we know that the bigger number is going to be under X because this is horizontal. And these 2 points labeled, the negative 4, 0, and 4, 0, those are the focal points. It doesn't label that, but that's what those are, so I'm telling you here now. The center is always smack dab in the middle of the focal points and right in the middle of the vertices. And so right in the middle of those would be 0, 0. That means the center is 0, 0. Okay, so we can kind of get an idea of what this equation is going to look like. It's going to be x squared over a squared plus y squared over b squared equals 1. Well, we know what A is. A is the distance from center to vertex. This thing here is A. So A is 7. That means A squared is 49. So we can replace the A squared with 49. Okay. We also know C is 4. C is the distance from center to focal point. So we have A, we know C, we can find B. We can use that little equation. A squared minus B squared equals C squared. We know A squared is 49. We don't know B squared. That's what we're looking for. And C squared is 16. So solve that, and b squared is 33. Keep in mind what we're trying to find here. We're trying to find b squared, so we don't want to square root this. We really don't care what b is. B squared is 33. So we can replace b squared with 33. And there's our equation. Right there. So it's all about finding the a, b, and c values, some way, somehow. All right. Last problem. Okay. So number 3, the way you know, first of all, in this chapter, it's going to be important that you can look at an equation and know what type of graph you're going to have. So we've talked about a parabola already. A parabola is when one of the terms is squared and the other one isn't. So like if you have y equals x squared or x equals y squared. So one of them squared, one of them isn't. An ellipse is if both of them are squared. So notice you have x squared and y squared. They're being added. That's going to be important because the hyperbola is going to look just like this, but it's going to be a minus sign. So they're being added, and then essentially you have fractions here, and you want the equation to equal 1. Okay? Now let's take a look at how we're going to graph this. Let's graph. Well, we know where the center is going to be. The center is going to be at -4, 3. So we're going to plot the center point at -4, 3. Left 4, 2, 3, 4, 1, 2, 3. I don't like graphing on the iPad. 1, 2, 3, 4, 1, 2, 3. Oh, fart. 1, 2, 3, 4, 1, 2, 3. There. So there's the center. Okay. Now, let's look at what else we could figure out. We know that a squared is the bigger number. All right, so what we can deduce from this, since the bigger number is under x, we know that the ellipse is going to be horizontal. It's going to look like this. Okay, so the bigger number is under the x term, so it's going to be horizontal. We also know if a squared, remember this is a squared right here. If a squared is 25, then a is 5. A is the square root of that number. And then remember what a is. A is the distance from the center to a vertex point. So that means the vertex point, well, there's 2 of them. They're each 5 units away from the center. So the question is, do we go 5 up, down, left, or right? Well, if the ellipse is horizontal, we're going to go 5 left and 5 right. So 1, 2, 3, 4, 5. Right here. And 1, 2, 3, 4, 5. So A is the distance from center to vertex, and we know it's horizontal because the bigger number is under x. B is, well, 4 is b squared, so b is 2. That means from the center we can go up 2 and down 2. Here, here. And so right away you see what that shape is. It is the ellipse, and we're just going to draw a nice smooth curve all around. It's not a kite, so we're not going to, or a rhombus or whatever that would be called. So we're just going to not connect the dots, but draw a curve. Okay, the other thing I want to find are the focal points. Where are the focal points? So remember, the way we find the focal points, we have to find C, little c. And there's a relationship between A, B, and C. It's a squared minus b squared equals c squared. Remember, C is the distance from center to focus. We know a squared is 25. We know b squared is 4. So c squared is 21. 21. That means c is the square root of 21. And I want to leave everything exact in this chapter. I really, especially when we have radicals, I don't want to turn these into decimals. So what that means is from the center, the focal points are left and right, radical 21. So if I want the ordered pairs of the foci, we can name those ordered pairs. From the center, so from -4, we are going to go left and right, square root of 21. That means we are going to add and subtract the square root of 21. So we can write this as -4 plus or minus the square root of 21, comma 3. Now we do need to figure out, the decimal approximation to plot the focal points. So if we were going to, let's see, the square root of 21 is about 4.6. So from the center, we're going to go left and right about 4.6 units. So 1, 2, 3, 4, really close to the vertex. You can So we have foci, we have vertex, we have center. And on the other side, we have a vertex, we have a foci. Or a focus, I should say. And there you go. So that's how you plot or graph an ellipse and find the focal points. I'm going to do save the bottom one for the end. So I'm going to go back. Again, I hope I'm doing this correctly. I guess we'll find out. All right. An equation of an ellipse is given. Now that looks nothing like the equation of the ellipse. Nothing at all. Okay. We need to make it look like the equation. Okay. So here's what we're going to do. It's a decent lengthy process. It involves completing the square like we did with the parabolas. And that process of completing the square, where you take half of b and square it and then factor and all that stuff, that's going to show up in every single conic section. So if you're not comfortable with it, we have to get comfortable with it. So here's what we're going to do. We are going to group the x's together. So x squared minus 4x. I'm going to leave a little space behind the 4x. And then we're going to have plus 9y squared plus 54y. Leave a little space. And I'm going to move the 49 over because we want the constant on the other side. So equals negative 49. Alright, so we group the x's, group the y's, move the constant over. So we haven't done anything yet. We just rearranged our stuff. Now we want to do some things. We want to get those quantities squared, and that process of getting those quantities squared is completing the square. So what we're going to do with the x group is we are going to take half of 4 and square it and create a c value. Half of 4 squared is 4. So we're going to add 4 here, which means we have to add 4 to the other side. The other thing, I guess I should have done this first, in that y group, we want we just want x squared and y squared. We don't want a number in front of it, so we should have factored out that 9. So I'm going to rewrite this line as x squared minus 4x plus 4 plus, and I'm going to factor the 9 out of the y group, y squared plus 6y. And over here we can write negative 45. We can combine those. In the y group, in the parentheses there, I want to complete the square. So take half of 6 and square it. And we get 9. Now here, we need to multiply. We didn't really add 9 to the left. We added 9 times. We need to multiply that 9 and that 9 together and add 81 to the other side. And then after you create those c values, now you can factor. So we're going to have x minus 2 squared plus 9 times y plus 3 squared, factor the parentheses, equals negative 45 plus 81. Well, negative 45 plus 81 is 36. So we're getting there. We now have the quantity squared, but now we want it to equal 1. So just like on the last problem, we're going to divide everything by 36. So now our equation, we have x minus 2 squared over 36. Plus, we can reduce the 9 and 36, so y plus 3 squared over 4 equals 1. So we essentially had to complete the square 2 times, and there's our equation. From here, we can do all the things we've done in the previous 3 examples. We know this ellipse is going to be horizontal because the bigger number is under x. We know the center is going to be at, I'm going to shrink this a little bit so I could fit everything in here. We know the center is at 2, negative 3. Here. A squared is 36, so A is 6, B is 2. So from the center we go left and right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, up and down 2. There's the ellipse. Find the focal points using a squared minus b squared equals c squared. We know a squared and b squared, 36 and 4. So 36 minus 4 equals c squared. C squared equals 32. So c is 4 radical 2 when you square root. So from the center now, keep in mind what we're doing. From the center, we're going right and left 4 radical 2. So from the center point, the x value is staying the x value is changing. The y value is staying the same because we're moving left and right. So the foci would be 2 plus or minus 4 radical 2, comma, negative 3. And then our decimal approximation for 4 squared root of 2 is about 5.7. So from the center, go left and right about 5.7. Again, this doesn't look too great on my iPad here, but that's all right. And then lastly, it says find the lengths of the major and minor axes. Well, if A is 6, then the major axis is 12. If B is 2, the minor axis is 4. All right, there you go. You do have an assignment. Quite a few problems to work on. Get some practice. If you have any questions, feel free to email me. Good luck.